Hey everybody, so this is the final lesson in our polynomials unit. It's a very quick unit. This one is kind of piggybacking off of the previous lesson, which was about the line of best fit. This one is called the curve of best fit. So basically the process of this is going to be the exact same thing, but the point is based on whatever the shape of the data looks like, given like whatever your table is, you should be able to tell whether the shape is linear, whether it is quadratic, or whether it is cubic. Now, linear is something that we've been working on since grade 9, maybe even before that. Quadratic was a grade 11 concept, so you should know what a quadratic equation looks like. And then cubic is the new one that we are learning this year. And it has that funky looking S shape. So kind of look out for that. Now, again, there is information here on how to use the TI-83 calculator. We are going to be using Desmos for this. And the way that we type in the regression equation on Desmos for a quadratic is y1, and then we've got the squiggly line. And keep in mind, quadratics have a squared term. They have an x squared term. So it's going to be a x1 squared plus b x1 plus c. Okay, so we have our squared term, we have our x term, and then we have our constant term. And our cubic function follows that same format as well, except now we have an x cubed. So it's a x1 cubed plus b x1 squared plus c x1 plus d. So basically just keep going down the alphabet, a, b, c, d for our coefficients, and then my powers go cubed and then squared and then just power of 1, and then our constant term. So we're going to run through a couple of examples. We are going to find the regression equation and then answer the questions that are there. So example number 1, there's no scenario or anything attached to it. We just have a table of values. We are going to determine what the curve of best fit is, and then we're going to solve for a couple of the values. So let's go ahead and jump over to Desmos, where we are going to enter in the table. So again, you've got your Desmos opened up here. Click the plus, click the table. You've got your x1, y1. So I've got -1, 6, 0, -1, 1, oops, 1, oh my gosh, 1, -3, 2, -1.5, 3, 5, 4, 10. And so if we look at this shape, it kind of goes down, and then it looks like it shoots up again. If we kind of zoom out here, there's our last point at the very top. So this clearly has like a bowl shape. So this is a quadratic equation that is opening upwards. So on our next line, we are going to put our regression equation. So y1, then our little squiggle, a x1. And now to get the squared, there's a couple of different ways you can do it. You can press shift and then 6. That is going to create a power of 2 exponent. Or if you click here in the bottom left, there's a keyboard or a keypad, has a bunch of extra buttons there. So this a power of 2 button, that is another way that you can make your x squared. It's not going to make the a squared, it is going to make the x1 squared. So as long as you type the x1 first, it should show up there. Then we've got plus b x1 plus c, and we get, I'm just going to lower the keyboard, we get our a, b, and c values. So we can go ahead and write the equation here, and also just keep in mind that when you are writing the equation, round your a, b, and c values to 2 decimal places. Never forget the 2 decimal places. You can do more than 2 decimals if you want, but 2 is the minimum, especially when it comes to that provincial exam. Make sure that you are writing your values to 2 decimal places. So this is y equals 1.68 x squared minus 3.91x minus 0.2 2, 3. Now the question also says to draw a scatter plot. I'm not going to worry so much about that. We did draw a scatter plot in the previous lesson, so I just want to focus on the regression equation itself. Okay, so I've got my equation written there. Now I'm going to determine the y value when x equals 9, and then determine the x value when y equals 3. So on Desmos, on a new line, I'm going to put the equation x equals 9, and then I'm just going to look for the intersection point. So the point where this line crosses my equation. And then I'm going to do the same thing for where y equals 3. So I'm going to jump back over to Desmos. It's a bit of a process here. There we go. So I've got my black line, that's my equation. So when I put x is equal to 9, I get a vertical line here. You can see here that they don't cross, but we can always zoom out by clicking the minus button, or we can always drag our line, or like drag our graph up, so we can kind of better visualize it. So the intersection is somewhere around here. There it is. Once I clicked on the line, it popped up. So when x is equal to 9, y is equal to 100.57. And we're going to do the same thing for y is equal to 3. So again, I'm just going to I'll click the home button. And you can see here there are actually two x values where y is equal to 3. So we have to make sure that we write both of the x values down. So one of my x values is at negative 0.65. And the other x value is at 2.97. So if I switch back over to my notes here, I've got them written down where y is equal to 100.57, and then my two x values are written there as well. So we're going to take a look at one more example on the next page. This question involves natural gas per gallon in the US. My x value is the years since 1982. So year 0 would be the year 1982. Oops. My year 1 would be 1983. And you can kind of keep going down the line. Each year, each number here represents the following year. So just kind of keep in mind what these numbers actually represent, because I have a feeling that it's going to come up later on in the question. So the first thing we're going to do is we are going to use our graphing calculator to produce a scatter plot, and we are going to decide what the best curve is for this data before we answer a couple of questions. So one more time, I'm going to switch over to Desmos. So I got that there. And I believe we can just click the X's here to get rid of stuff. And we can start fresh with a new table and a new regression equation. So I have 0, 5.17. I'm going to go ahead and just put these numbers in here, 4, 5, 6, 7, 8. Kind of save a bit of time since it is just increasing by 1. Very easy to do. 6.12, 5.83, and again, these numbers here represent the price of natural gas. And 5.77. Also, make sure that you double check when you are putting these numbers in. You might make a little typo somewhere that could lead to a mistake in your data. So make sure you are very careful with that. We can also kind of adjust the window here. So my x values go from 0 to 8. So maybe I want my x-axis to go from -2 to 10. And my y values seem to fluctuate between 5 and 6. So maybe we can adjust our y values to go from 4 to 7 to kind of get a better visualization. You don't have to do this if you don't want to, but you can. It can help visualize what is going on with the data. So you can see here that we have this like S shape. So this is going to be a cubic function, okay? So in part A, it says use your calculator to produce a scatter plot. We did that. Part B, draw the graph and describe the trend in data. Again, I'm not going to draw the graph here. You can see it here for yourself, but I would say the trend is it's fluctuating. It's going up and down. And I'm going to flip back to my notes in a moment, but I did write that down in my notes because I want to keep Desmos open so we can create that curve of best fit. So again, this is a cubic function. So I have y1, then the little squiggle. I'm going to open up the keypad for this one just to show you how the powers work for this. So I have a, x1, and then if I want to do power of 3, I'm going to click this AB button, which is going to create a power, and then I can put a cube there. Also, make sure if you keep typing at this point after you put the cube, so if I put plus, we don't have to worry about it continuing on in the exponent. So just kind of watch out for that. Make sure that your equation is typed in properly. Plus c x1 plus d. And so we get a curve that somewhat matches our data. I'd say that it fits the trend very well. And we get an A value of 0.021, B is negative 0.27, C is 0.92 if we round it, and D is 5.25 if we round it. So I'm just going to go ahead and write this down, and then I'm going to flip back to my notes in a moment. So we have 0.02 x cubed minus 0.27 x squared plus 0.92 x plus 5.25. So I'll flip back. You can copy that down as well. So in part B, I wrote that the trend is that it's fluctuating, it's going up and down. Maybe you have another way or a better way to describe what it looks like. If your teacher in class might have a different way of explaining, but I'd say that's a pretty good explanation. And then I got my curve of best fit written here. So part D says, determine the price of natural gas halfway through 1986. So we have, we already started writing 1982, 1983, 1984, 85, 86, 87, 88, and so on and so on. Okay, so halfway through 1986, well, 1986, the value of that is 4. So if we are going halfway through 1986, that's going to be halfway between 4 and 5. So what we are going to put in here is we are going to find the intersection point for x is equal to 4.5. And we're going to find the intersection point. All right, and then in part E, it says, when does the price rise above 6.10 for the first time after 1982? So we're going to plug in y equals 6.10, and we're going to find the first intersection point. Okay, so let's do those two things. So one more time, we are going back to Desmos. Let's put that equation here. The first one was x is equal to 4.5, and we're just going to click on that intersection point. We find that the price is equal to $5.75. So because we are talking about price, it's a good idea to round to 2 decimal places. And also don't forget your money sign. And then for the second one, we have y is equal to 6.10, which you can also just put 6.1 on your on the graphing calculator. So the first time that it crosses that line is at this point right here. So the x value of that is 1.60. So what year is that? Well, just going to flip back to the notes one more time. But if it's 1.60, that means that it is sometime between year 1 and year 2. So I would say it's about 60% through 1983. My camera just disconnected, so I'm going to try to explain this one more time. I'm not too sure where it cut out. So at x equals 4.5, which is halfway through 1986, the price is $5.75. So because we're talking about money, make sure you round it to 2 decimal places and include the money sign, because we're not just looking for what the answer is, we're looking for your interpretation of the answer. Same thing for this question here. Yes, the intersection point gave us an x value of 1.60, but what does that actually mean? Well, the 1 represents the year 1983, so 1.60 is 60% through the year 1983. So make sure you don't just include the answer, but include your interpretation of the answer as well. So there are a few practice questions on the next page, but the main takeaway is make sure that you are familiar with the shapes of the different graphs, that you are picking the correct regression equation, and once you've got that, I mean, you're already most of the way there. So just make sure that you are interpreting the information that the question is asking you.